The periodic table organizes its 118 elements into groups with similar properties and places them in order of increasing atomic number. The atomic number of the element is the number of protons in the nucleus of the atom. So there's actually a typo here. It says increasing atomic mass. Actually, Dmitri Mendeleev, the developer of the periodic table, arranged the elements in order of increasing atomic mass because he didn't fully understand atomic number at the time. And it was actually that arrangement that helped to develop an understanding of atomic number. In this video, we want to use the periodic table to identify the group and period of an element, identify the element as a metal, a nonmetal, or a metalloid. In the periodic table, elements are arranged according to repeating similar properties. Groups contain elements with similar properties in vertical columns. Periods are horizontal rows of elements counted from top to bottom of the periodic table as periods 1 through 7. So we can see here the groups are the vertical columns and the periods are the rows. And we have 1, 2, 3, 4, 5, 6, 7. That's demonstrated again here on this smaller periodic table. We see the groups in the vertical columns and the rows 1 through 7 from top to bottom. Group numbers are written at the top of each vertical column. We use the letter A for the representative elements, which are also called the main group elements, and the letter B for the transition elements. There's another system that uses numbers 1 through 18 for all the groups from left to right in order. Because both systems are currently in use, they're both shown on the periodic table in this text and are included in our discussion of elements and group numbers. Vertical columns represent groups of elements and horizontal rows represent the periods. We see the groups again here. We have the two different methods represented. First, we have the main group elements and transition elements labeled as group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, and the transition elements listed as 1B, 2B, 3B, 4B, 5B, 6B, 7B, and 8B. And these lists correspond to, for the transition elements, the way that these elements will lose electrons or bond. The other method lists the columns in order from left to right, 1 through 18. So we have group 1, 2, 3, 4, 5, 6, all the way to 18. We can also give our groups names according to the column that they're in or the way that they bond. We have the alkali metals in group 1A, the alkaline earth metals in group 2A, and then we have the transition elements shown here in gray. We have in blue, we don't have a common name for this particular set of elements. We have the halogens in purple and the noble gases in pink. The alkali metals shown in group 1A include lithium, sodium, potassium, rubidium, and cesium. We see that here. They have similar properties in that they lose one electron and form ionic species. We have the alkaline earth metals in group 2A. We have beryllium, magnesium, calcium, strontium, barium, and radium shown here. And these tend to lose 2 electrons and form ionic species. The halogens are in group 7A. They include fluorine, chlorine, bromine, iodine, and they tend to gain an electron and form anions. Next, we have some multiple choice questions. Identify the element described by each of the following groups and periods. Group 7A, period 4. Group 7A, period 4 would give us bromine. So we see bromine here. Next, we have group 2A, period 3 and group 5A, period 2. So we have group 2A, period 3 is magnesium, and group 5A, period 2 is nitrogen. So we get magnesium and nitrogen. We have a major dividing line on the right side of the periodic table, which separates the metals from the nonmetals. The metals are on the left and shown here in blue. The nonmetals are on the right and shown here in yellow. The metalloids are right in the center, and the dividing line is in black, and the metalloids are shown here in green. Next, we'll look at some characteristics of metals, nonmetals, and metalloids. Metalloids, which are located along the heavy zigzag line on the periodic table, exhibit properties of both metals and nonmetals. They're better conductors than nonmetals, but not as good as metals. They're used as semiconductors and insulators because they can be modified to function as both conductors and insulators. Aluminum and aganacin aren't classified as metalloids because aluminum retains the properties of the metals and aganacin retains the properties of a noble gas. Comparing the characteristics of a metal, nonmetal, and metalloid, for example, are shown here. Silver is a metal, antimony is a metalloid, and sulfur is a nonmetal. Silver is shiny, ductile, can be hammered into sheets and drawn into wires, is a good conductor of heat and electricity, and is used in coins, jewelry, and tableware. It has a high density and a high melting point. Antimony is a metalloid. It's blue-gray and shiny. It's brittle. It shatters when hammered. It's a poor conductor of heat and electricity. It's used to harden lead, color glass, and plastics. Has a density of 6.7 grams per milliliter, so kind of in the center, and it has a melting point of 630, so between a metal and a nonmetal. Sulfur is a nonmetal. It's dull and yellow and brittle. It shatters when hammered. It's a poor conductor of heat and electricity, but a good insulator. It's used in gunpowder, rubber, and fungicides. It has a density of 2.1 grams per milliliter, so much lower than a metal in general, and it has a melting point of 113 degrees C, which is much lower than a metal, for example. Let's see if we can identify the following as a metal, a nonmetal, or a metalloid. First, we have sodium. Sodium is on the left of the periodic table, so it's a metal. Let's go ahead and draw our dividing line again so we'll know where our metalloid line is. Okay. Chlorine is to the right of this dividing line, so it's a nonmetal. Silicon is on the line, so it's a metalloid. Iron's abbreviation is Fe. It's right here. It's to the left of the line, so it's a metal. Carbon is right here. Carbon is not directly on the line. Carbon is a nonmetal. Next, we'll match the following elements with the description. Let's go over to the periodic table. So first we have the metals in group 4A. Next we have the nonmetals in group 5A. And finally, metalloids in group 4A. So let's first define our dividing line. So we were asked for the metals in group 4A, and we have tin, lead, carbon, silicon, and germanium. So here is group 4A, and on the list we only have tin and lead as metals because germanium is on the dividing line and these two are above on the line or above the line. So tin and lead will be the only metals on that list. Next, we have nonmetals in group 5A. So group 5A is here. We want the nonmetals this time. The nonmetals are to the upper right of the periodic table beyond the dividing line. So on the line we have arsenic, so that one doesn't count. But above the line we have phosphorus and nitrogen. So those will be our nonmetal choices. Next, we want metalloids in group 4A. So the metalloids in group 4A will be silicon and germanium. Next, we'll consider some elements that are essential to health. Of all of the elements, 20 of those are essential for well-being and survival of the human body. 4, oxygen, carbon, hydrogen, and nitrogen, make up 96% of our body mass. Most of our hydrogen and oxygen is bound up in water, which makes up about 50 to 60% of our body mass. We also have some macro minerals: calcium, phosphorus, potassium, chlorine, sulfur, sodium, and magnesium, which are located in period 3 and 4. These are involved in the formation of bones and teeth, maintenance of heart and blood vessels, muscle contraction, nerve impulses, and acid-base chemistry of the body. They're also involved in cellular metabolism. So we see those in period 3 and 4 here. So we have the major elements in the human body shown in the red blocks, which are hydrogen, carbon, nitrogen, oxygen. These are often found in organic molecules, which means they're comprised of carbon sources. Next, we have macro minerals, which are shown in blue, and these are in row 3 and 4. Okay, and then we have some micro minerals or trace elements, which are shown in purple here. Elements from the periodic table comprise all of the matter in the world around us.